In this series of lecture segments, I'm going to describe in detail some of the research showing how social factors like authority figures and peer groups can influence how people think and act. I'll begin with a classic experiment that Stanley Milgram performed starting in 1961 that's been replicated many times. The experiment's a little complicated and the results are quite shocking, so I'm going to take you through it by having you imagine that you're the participant being tested in the experiment. You'd start by seeing this advertisement for a study of learning and memory, and then you'd go to a lab at Yale University to participate in this study. You and another participant come at the same time, and you're each paid $30 in advance for your participation. It was actually $4 in the original experiment, but that's close to $30 now after adjusting for inflation. The experimenter tells you that one of you will be the learner in the experiment, and the other will be the teacher. The experimenter has each of you pick a slip of paper to determine, at random, which of you will be the learner and which of you will be the teacher. One slip says teacher and the other says learner. Your slip says teacher, so you'll be the teacher and the other participant will be the learner. Both of you are then shown the shock generator that you see here. The shock generator has 30 little levers corresponding to 30 different shock levels. The labels indicate that the shock levels range from 15 volts, labeled slight shock, through levels labeled very strong, intense, extremely intense, danger, severe shock, and finally, at 450 volts, an ominous XXX. You're hooked up to the shock generator for a moment and given a 45-volt shock so you can see what it feels like. This is labeled in between slight shock and moderate shock, and you can feel that it's mildly painful. Then, the experimenter takes you and the other participant, the learner, into an adjacent room, where the learner is strapped into something that looks like an electric chair and connected to the shock generator. The learner tells the experimenter that he has a mild heart condition, but the experimenter says, although the shocks can be extremely painful, they will cause no permanent tissue damage. Imagine that you're actually in this situation. The other participant, who has randomly been assigned to the role of learner, has a heart condition, and he's been hooked up to a shock generator that can deliver 450 volts. Would you be feeling just a little bit nervous? Now you're taken back into the room with the shock generator, and the experimenter closes the door between your room and the learner's room. So, you and the experimenter are in one room, and the learner is locked into the room next door. You're told that you'll be teaching the learner word pairs. You start by reading each of the word pairs to the learner over a microphone. Dog, chair, shirt, carpet, etc. Then you have a series of trials where you say the first word in a pair to the subject over the microphone, followed by 4 possible answers. For example, you might say dog and then give the possible options night, chair, handle, and can. The subject would then press one of 4 buttons to indicate the right answer, which in this case would be chair. And then you'd see what button they press in a little display in front of you. If the learner gets it wrong, you're required to press one of the 30 buttons on the shock generator to give the learner a shock. For the first error, you use the lowest shock level, 15 volts. Every time the learner makes an error, you're told you need to go up to the next shock level, which adds another 15 volts. And you're required to announce the shock level each time. So for the second error, you say 30 volts, and then you press the 30 volt button. And for the third error, you say 45 volts and press the 45 volt button. By the time the learner has made the 9th error, you're giving a 135 volt shock in the middle of the range labeled strong shock. Would you be starting to get nervous about going any higher? Would you ask the experimenter if it was really okay to keep going? After more and more trials, eventually you get into the extreme intensity range. You get to 300 volts and suddenly you hear the learner pounding on the wall. And after the next word you read, the learner doesn't press a button to give you an answer. What do? You might turn to the experimenter and ask, what should I do? The learner hasn't responded. Is he okay? Should I keep going? The experimenter tells you that you should treat a non-response like an incorrect response, again increasing the shock intensity every time. So you do another trial, get no response, and give the learner the next highest shock. You ask, should I really keep going? I'm getting near the danger range. The experimenter says, please go on. You do another couple trials with no response, increasing the shock each time. You ask the experimenter, do I really need to keep going? The experimenter says, the experiment requires that you continue. You say, I'm willing to give back the $30, I just want to stop. The experimenter says, it's absolutely essential that you continue. Would you keep going all the way to 450 volts? Or would you just refuse to do it at some point and walk out of the room? I'd like you to get out a piece of paper and a pen and write down 3 numbers. First, write down the voltage at which you think you would refuse to give any more shocks. Would you stop at 135 volts, the middle of the strong shock range? Or maybe at 300 volts when the learner pounds on the wall and then stops responding? Or would you go all the way to 450 volts? Second, write down the voltage at which you think most people would stop. And third, write down the percentage of people that you think would go all the way to 450 volts. Write down these 3 numbers, and then you can take the embedded quiz question for this lecture segment. We'll discuss what the participants in Milgram's experiment actually did in the next lecture segment.